I'm delighted to present my paper at WACV 2024. I am Kanghyeok Ko from Chungang University in South Korea. The title of our paper is ZIGNeRF, Zero-Shot 3D Scene Representation with Invertible Generative Neural Radiance Fields. The objective of our research is generating 3D, consistent representation of real-world images via zero-shot estimation of latent codes. In 3D GAN inversion domain, our main contribution is this is the first study that requires no additional training steps and camera parameters. Various attempts have been made in the past, however, each had its limitations. In the case of 2D-based GAN inversion, there were issues regarding 3D inconsistency. Moreover, in the case of 3D-based GAN inversion, it either required camera parameters for input images or necessitated additional training steps specifically for input images. Therefore, we aimed to address these issues. We approached the problem by combining GN inversion with Generative NeRF. Mapping input images through GN inversion to the learned latent space of Generative NeRF enables us to generate multi-view images corresponding to the input. The architecture of ZIGNeRF is divided into two parts. The first part is the 3D generation component, while the second is the inverter. The training of ZIGNeRF occurs in two stages. First, the complete training of the 3D generation part, followed by the training of the inverter once the 3D generation part is fully trained. The 3D generation part is an improved version based on the GIRAFFE model presented at CVPR 2022, which we have enhanced. We experimentally confirmed the instability in the training of GIRAFFE's neural renderer and addressed it by introducing a residual network and spectral normalization, stabilizing the training process. Furthermore, we achieved performance enhancement in the discriminator with residual blocks. After training the generator and discriminator, we utilized them to train the inverter. During the training process of the inverter, the generator and discriminator remain frozen. The training process of the inverter is as follows. The generator creates samples using the source latent code, camera parameters, and compositional parameters. Next, the inverter predicts the latent code of the input image. After prediction, generator reconstruct the image with predicted latent code and source parameters. The objective function is what is shown at the bottom of this slide. First, calculate the loss between the source latent code and the predicted latent code. And then, calculate the loss between target image and reconstructed image by using L1 loss and perceptual loss. Finally, input the reconstructed image into the discriminator to calculate the realistic loss. The figure included in this slide depicts the model validation using CelebA-HQ and AFHQ images. We conduct zero-shot image generation without additional network training, based on the input images. This is visualization of reconstructed images based on input CAR image with compositional operations. We use CAR dataset, which is called CompCars. We demonstrated the robust feature extraction capabilities of our model. The images on this slide showcase the results of applying the model trained on the CelebA-HQ dataset to AFHQ images. It performs well even on entirely different datasets. Our model also demonstrates intriguing additional experimental results. The first is style mixing. Our model takes two types of latent codes as input, where one determines the shape of the output image, and the other influences the appearance. As evident from the experimental results, we observe outputs that combine the shape from the left image and the appearance from the right image. These outcomes represent the first attempt in the domain of 3D GAN inversion. The image on the right side of the slide shows the result of taking images of two different vehicles as inputs and producing a single scene. This is a result where we effectively utilized the compositional features of GIRAFFE, which we used as the baseline model. The following are the quantitative results. Since this is the first study attempting zero-shot 3D GAN inversion without camera parameters, there are no direct comparison benchmarks available. Hence, we compared our model with GIRAFFE, which served as the baseline model, for evaluation purposes. The unconditional in the table represents simple generation performance. For the conditional model, it showcases the performance of our model in generating images based on the inferred latent code from input photos. It's evident that our model exhibits significantly better performance than the baseline model. ZIGNeRF is first learning-based 3D GAN inversion with no requiring camera parameter during the estimation of latent codes. Inverter is introduced to obtain latent codes for unseen objects. Thank you for listening.